The slope of a tangent line. That's one of the two problems of calculus, right? There was the area and the differential calculus. That's what this is all about. Slope of a tangent line. And integral calculus was all about the area under a curve, which of course was something the Babylonians were working on. So that was kind of the first problem that came up. And it was Newton and Leibniz who were working on this problem. So, slope of a tangent line. So in geometry, the tangent line, or simply the tangent to a curve at a given point, is a straight line that just touches the curve at that point. So here's three curves, and you are to draw in a tangent line. Okay, so of your own. And all of ours should look pretty similar, right, if we're drawing a tangent line. So we want a line that touches the curve, and so we don't want a line that cuts through, right? You can't, oh look, there's a tangent. Oh wait, that didn't even go through the point, right? There, no, that's not a tangent line. So you want the tangent line, right? Because there is only one line that will be tangent to a curve at, not that I can draw either, but. Okay, so there's the tangent line, right? There we go. That's a little better. And we need a tangent line to this curve as well. And the idea is, well, we want to be able to find the slope of this line, right? How do we find the slope of this line? So imagine, or you don't have to imagine, I guess we can look here. If a secant line is drawn through 2 points, P and Q on a curve, and you take the point Q and you start moving it, so here'd be the first sort of secant line. Right, and now if we take point Q and start to move it closer to P, there's another one. There's another one. And you can see that we're going to get close to the tangent line, right? The closer we move Q to P, the closer that the secant line will rotate towards the limiting position, which occurs when Q meets P. The line at this limiting position is the tangent line Q. Therefore, the slope of the tangent line is the limit of the slope of the secants as Q approaches P, right? So imagine this sort of rotating. Actually, you won't even have to imagine. I'll show you a demonstration in a sec. Use diagram below to write a formula for the slope of the secant QP. So we've got point P, which is at A, f of A, and we have point Q, which is at x, f of x. And so, what's slope? How do we get slope? Right, the slope is rise over run. The slope is rise over run. And do we have a formula for rise over run? Yeah, y2 minus y1 over x2 minus x1. Okay, so we're going to take this as being x2, y2, and this will be our point x1, y1. And so the slope of the secant line is going to be f of x, which is y2, minus f of a, which is y1, over x, which is x2 minus a. So that's the slope of the secant. And now we've got a couple of formulas there. Let's back up for a sec. Let's go here. So this is showing a secant line, right? And you know, we want slope, so we need the vertical. So let's see if I can't make that do that. So there's the vertical. Now here we're using this is going to be the point x, f of x, and this is going to be the point x plus h. Okay, so we've added h here, right? So if this has coordinates x, this is x plus h, and then its y coordinate is f of x plus h. And so that's shown here, right? We've got f of x plus h minus f of x, and here we've got x plus h minus x, which is just h. pull that out of there. And let's show the tangent line. So there's the actual tangent line. That's what we're going to approach, right? So as we start to move, if I make h, see a little slider on h is 3.2 units long, and if I want that to be 0 units, right? I want to get h down to 0. And we'll also show the slopes. So there's the secant line, and now I should be able to pick this up and start to, hey, whoops. All right. Board stuff. Hang on, I'll do it on the, I'll do it on here. If I hold too long on the board, it takes it as a click. So as I lower h, you can see that the secant line, right, which is PA, is getting closer to the blue line. You can see the slopes are getting closer. And when I get down to 0, now the secant line is undefined, right, because I'm trying to divide by 0. And even if you're going the other way, so if the h is over here, you know, at -5. So we want to get, as h approaches 0, then the slope of the secant line is going to approach the slope of the tangent line, which is what we're looking for. All right, so that's kind of a nice demonstration of that. So the slope of the tangent x equals a can be determined using either of the following two formulas, right? So we have formula 1. The slope of the tangent is x equals a. Is the limit as x approaches a of the slope of the secant, okay? So if you're looking at your diagram, right, we want x to move to a, to point P, which is the formula that we just developed on the other side, right, which was f of x minus f of a over x minus a. And in formula 2, we're going to let x equal a plus h. So think of the GeoGebra thing we just saw, right? We want the h to come down. So we're going to take this, but you know, x is a plus h, right? So we're going to write a plus h here. We want a plus h to approach a. And where we see x, we're going to write a plus h minus f of a, and where we see x, we're going to write a plus h minus a. Now, what's going to happen on the bottom? Well, we got a plus h minus a, so that's just going to be h, right? So we want the limit as, we're going to get rid of these a's, we'll subtract a from each of these guys, and we get the limit as h approaches 0. Right, and that matches up with the demo we just looked at. We want h to approach 0 of f of a plus h minus f of a. Okay, and a, that's the point, right, at which we want to find the slope of the tangent line, right? Because we were dealing with point P, excuse me, which on the diagram was at a and f of a. Okay, so two formulas, no waiting. Equation of tangent line to determine, so now I want the equation of the line, right, the tangent line. In order to get the equation of a line, you need two things. What do you need? You need the slope of the line, and you need, what else? A point on the line, right? Yeah, that could be a y-intercept, right? But it's just any point on the line. So a point on the line. Equations of line can be expressed in general form, ax plus by plus c equals 0, a, b, and c are integers, and a is greater than 0. And in slope y-intercept form, y equals mx plus b. Right? So could be asked for either form. And just remember, a, b, and c are integers, a is positive, right? A has to be greater than 0. All right, here we go. Determine the equation of each of the following lines in the form ax plus by plus c equals 0, where a, b, and c belong to the integers, and a is greater than 0, right? So we got, you know, you're not going to have 2/3 x, right? You're not going to have 2/3 x plus, you know, we have to have integers. Okay, so we have the curve. If f of x is 3x squared minus 2x plus 1, use formula 1. I actually kind of like Formula 2, but in car racing, Formula 1. Use Formula 1 to determine the equation of the tangent line at x equals -1. Okay, so in other words, we need a tangent, and there's got to be some point on this curve where we are finding the tangent line. Okay, so what's Formula 1 say? Formula 1 says that the slope is equal to the limit as x approaches a of, what is it, f of x minus f of a over x minus a. All right, now, well, where's our a value? Our a value is at -1, right? That's where like point P is. We want the point tangent there. So we're going to say, all right, I want the limit as x approaches -1 of f of x minus f of -1 over x minus -1. Right? Because that's our point. That's our a value. That's the p in, we got the q moving closer to the p. All right, well, what do we know? Well, we know f of x, right? That's defined for us here. So this will be the limit as x approaches -1. Okay, so f of x is 3x squared minus 2x plus 1. Let's get brackets around that, right? Because I want to keep that kind of separate. Minus f of -1. Okay, so minus. So I definitely want brackets around these, or parentheses. I shouldn't drag the definition off. So f of -1 would be 3 times -1 quantity squared minus 2 times -1 plus 1. Okay, and let's throw brackets around that over x plus 1. Right, x minus -1 is x plus 1. All right, so if we play with this, maybe it will be nice and we can get rid of that x plus 1 on the bottom, right? Because we can't take x to -1, we'd be dividing by 0. But who knows? Let's see what's going to happen here. Equals. So we're not yet at the point where we can replace the x with a -1, right? We do that, we get a 0 on the bottom, we can't do that. So let's expand this. So we're going to expand this, we'll remove, well, let's work this out. So what's this work out to? What do we got? 3 plus 2 is 5 plus 1 is 6, right? So that's like 6. Okay, so removing brackets, we're going to get 3x squared minus 2x plus 1 minus 6, sorry, minus 6 over x plus 1. Okay, so let's just keep working. Limit as x approaches -1 of, okay, what do we got? 3x squared minus 2x minus 5 over x plus 1. You can imagine what could possibly happen next. We could factor this, and what are we hoping one of the factors is? Yeah, so if one of the factors up here is x plus 1, I'm not saying it is, but if it were, then it would cancel. Then what would the other factor be? I like this because it's sort of factorless factoring, right? You just say, well, okay, I need a 3x up front, right? And then a minus 5. Now, I didn't really factor anything, so I better check this. I was just sort of hoping that this factor is x plus 1. So what do we got? 3x squared plus 3 minus 5 is minus 2. Oh, good. So it does factor. And one of the factors is x plus 1. So we can do what? Cancel. Yeah. All right. Let's just write this. And now we can put the -1 in, right? Okay, so now we can drop the limit. So this is equal to 3 times -1 minus 5, which is -8. And by now we've forgotten what this thing was. What is that -8? It's the slope of the tangent line, right? Okay. like disappeared way off the top, right? But at the front there, somewhere way up top, it says m equals, right? That's what we're working out. We're working out the slope of the tangent line. So we know the slope of the tangent line is -8. Okay, let's go back over here. So m equals -8, right? What do you need to find the equation of a line? Slope and a point on the line. Well, what's the point? Okay, well, we know that it's when x is -1. So the point is -1, and we actually kind of worked that out already, right? F of -1 is 6. So we want to find the equation of the line with a slope of -8 that goes through the point -1, 6, because that's the point on that curve, right? -1, 6 is the point on f of x through which this line is going to be tangent, or at which this line is going to be tangent. Okay, so use your favorite, whatever you do to do straight lines. I like y minus y1 equals mx minus x1, right? So it becomes y minus 6 is -8 x plus 1. Minus 8. I could very nicely go into slope-intercept form. As a matter of fact, let's do it because it's really the precursor to, so -8x, what have we got, -2. But that's not what they asked for. They wanted general form, so move the 8 over. Now, there's no fractions here. It's nice, right? The slope was just 8, -8. So what do we got? Positive 8x plus y plus 2 is equal to 0. And you might wonder, so what does that look like? So having anticipated, you might say, what does that look like? So here's our curve, 3x squared minus 2x plus 1. Right? We wanted the point -1, 6, which is kind of, let's shrink that a bit. There we go. So there's the point -1, 6, right? And what did we say this was? 8x plus, I don't know if I could type this in this way. No, apparently I can type it in that way. So there's the line 8x plus y plus 2 equals 0. And I think you see there's a little point. You can put a point there, right, at the point of tangency. It put the point, so -1, 6, and there we go. I don't know if we can zoom in, maybe move that down a bit. You see, actually, when you zoom in, right, what happens to a quadratic, right? I mean, you zoom in enough, it looks like a straight line at a certain point, right? So we're getting close to that. We'll zoom out a bit. You can see some. Hey, come on. You can start to see a little separation there, I guess. But, anyways. So, any questions on this one? Formula 1, right? Slope, limit as x approaches a, etc., etc. And let's do another one. Use Formula 1 to determine the equation of the line tangent to f of x equal. At some point, I think you're going to run out of room on the sheet. I think at this point, there is now no room on the sheet. So if you want to write this stuff down, you'll have to get out a sheet of paper. All right, so we want to find the equation line tangent to f of x at x equals 4. It asks us to use Formula 1. So Formula 1 is the slope is equal to the limit as x approaches a of f of x minus f of a over x minus a. Right? So it's the limit as x approaches what value? 4. Right? We want the x value to be 4. Of f of x, which is what? 3 over x plus 2 minus f of a, which is 3 over what? 4 plus 2 over x minus a, or x minus 4. Okay. So that's what we want to work out. Okay, how much detail do you want in this solution?
All of it.
All of it, all right. So the limit as x approaches 4, so we've got 3 over x plus 2 minus, what's 3 over 6? 1 half, so minus a half. Okay, now, fine, I don't like fractions, so I'm going to do this, right? I'm going to say times 1 over x minus 4. Okay, well, it's not fractions so much. I don't like compound fractions, right? I don't like compound fractures either, but. All right, the limit as x approaches 4. All right, how much detail do you need for simplifying this? Very much detail? So much detail. Okay, what's our common denominator?
2 times x plus 2.
2 times x plus 2, right? Need one of these, need one of these. So let's write it 2 times x plus 2. This, the 1 over x minus 4 is just along for the ride. Okay, what do we got to do to the 3? Okay, so the 3 is just over an x plus 2. It has to be multiplied by 2, right? If we're going to throw a 2 on the bottom, we're going to put a 2 up top with the 3. Minus, what are we going to do with the 1? We're going to have to multiply it by x plus 2, right? Okay. So what do we got? 6 minus x. Do I need to go 6 minus x minus 2? Can I just go 4 minus x? Yeah. Okay, great. All right, so are we okay with this line? How we got it, where it came from, right? We've got the 6 minus x minus 2, and we just decided that we would go 6 minus 2 is 4, and we go 4 minus x. Does anything cancel? Yeah, maybe. What?
Oh, wait. -1.
Yeah, so if I cross off the x minus 4 and the 4 minus x, I could do that as long as I put down a -1, right? So we can think of this as, you know, the negative of. I put a negative sign in front of this, it becomes -4 plus x, which is this guy. So these guys cross, and this becomes a -1, right? And, all right, so let's just write that out, and then we'll remove. So one more line with the limit. So what do we got? -1 over 2 times x plus 2. Which is equal to what? Because I put 4 in now, right? We've gotten rid of this. This was the obstacle. -1 over 2 times 4 plus 2. So -1/12. Okay, forgot what we were doing. What's the -1/12? Oh, I got some stuff to do. That's the slope. That's right. Yeah. Oh, right. We're doing slope. Remind me to get these out. They are grad newsletters. Okay. All right. Let's do my job because there's a member of the committee in the class. So checking up on me. What's his name? Rough Rider signed, defensive end, John, check 2 contract extension 326. Yeah. Well, we all have our alerts, right? Okay, so what do we got? The slope is, and what's the point? No, the point is to learn calculus, but okay. Fell for that one. It's 4 and f at 4, right? And this is f of 4. This is where we worked out f at 4, and so this is 1/2, right? So we've got the point, 4 comma 1/2. We've got the slope. We've got the formula for a equation of a line given point and slope, right? Use your favorite. I mean, there are variations of this formula, so whatever you like. So what do we got? Y minus 1/2 is negative 1/12 x minus 4. Yeah, you got to get rid of fractions and stuff, right? So I don't know. 12y minus 6 is negative 1. And what do we get? X plus 12y minus 10, whoops, equals 0. Yeah, I think that's it. So, is that true? What was the... What do we have? 3 divided by x plus 2. And what was this guy? X plus 12y. X plus 12y minus 10. Oh, well, you gave us the point. 4 comma 0.5. So there we go. So that's what this one looks like, right? I mean, you don't need this. I don't know if it helps to see it. Certainly, I don't think it hurts to see it because you can actually see that, hey, this looks right. That's something you can do at home too, right? If you want to check your answer without looking in the back of the book kind of thing, then you could graph the two curves in Desmos and just sort of say, hey, so am I seeing it? Yeah, look, I'm seeing this, and it is a tangent, and that does have a slope of, negative 1/12, and yeah, looks good. Okay. I'll leave that back up there for a sec in case anybody was still typing, writing in cursive. Anybody use cursive? They still teach that?
No, nobody ever uses cursive.
Only when I swear I'll use cursive. Use formula 2 to wait. There's a thing after we're done and stop recording. I'll show you this. Use formula 2 to determine the equation of the line tangent to y equals 3 root x plus 1 at x equals 8. So I kind of like formula 2 a little bit better in the sense of its limit as h approaches 0. We've been doing all that limit stuff, right, as h approaches 0. So formula 2 is what? M is equal to the limit as h approaches 0 of f at a plus h minus f of a over h. Okay. So what do we got? The limit as h approaches 0. So what's f of a plus h? So what's f of x? Yeah, which is y, right? Wherever you see y, you can put f of x, right? Okay, so this is f of x is equal to 3 root x plus 1. Okay, I want f of a plus h. So what is it? 3 times the root of a plus 1? So 3 times a plus h plus 1 minus 3 times root of a plus 1, right, over h. We're going to get the h out of there. only partially on purpose. Oh, but wait, what else do we know? We want it to be when x is equal to 8, right? Okay. So let's make that a an 8. There. That's better. That's nicer, right? Okay, so let's clean that up a bit. So what do we got? 3 root 9 plus h, yeah? Minus what? 3 root 9. But what's another way to say root 9? Yeah, 3.
Times 3 is 9.
Yeah, 9. Ultimately 9. Okay, there we go. Okay, cleaned up. But we got to get rid of that. So we need a strategy, right? Which was to do what? We're going to have to rationalize the numerator, right? Hoping we get a stray h up top. Okay, so what's the thing we're going to multiply by?
3 root 9 plus
Yeah, plus 9. Over
same thing.
the same thing.
Oh my God,
This is where the width of the paper comes in handy. Okay, so up top well, here, let's bracket everything nicely. So we've set it up, right? It's a difference of squares we've set up, right? So what is that ultimately? It's the square of the first term minus the square of the second term. So what's the square of 3 times the root of 9 plus h? Okay, so 3 squared is 9, and root 9 plus h squared is 9 plus h. Okay, so we have 9 times 9 plus h. Minus what? 81 over h times 3 root 9 plus h plus 9. Okay, so what's that simplify to up top? 81 plus 9h minus 81, which is just 9h, right? Okay, so 81 plus 9h minus 81. Ooh, 81's are gone, just 9h. And on the bottom, oh, well, there's our little stray h, right? Yeah, kill it. Okay, no, we'll become cross with it. So now the h's cancel, right? So now what? Now you can put 0 in for h, right? There's no impediment. So what's that equal to? Well, so we've got 9 over 3 root 9 plus 0 plus 9. I think that's just another 18, right? Whoops. Okay, so root 9 is 3, 3 times 3 is 9, plus 9 is 18. 9 over 18, or 1/2. So what did we just find?
Slope.
The slope, right? Yeah. So hey, we're halfway there, right? So determine the equation of the line tangent to at x equals 8. Okay, so we know the slope is 1/2. We know the x value is 8. The corresponding y value is 9, right? That was worked out here, right? Okay, so we've got m is 1/2, and the point is 8, 9. Right? And if you've forgotten that this was, just put an 8 back in here, right? Go 8 plus 1 is 9, and root of 9 is 3, and 3 times 3 is 9. Okay, and you'll get if you forgot you did that already here. Right, so what do we write? Y minus y1. x minus x1. Y minus 9 is 1/2 of x minus 8. 2y minus 18 is x minus 8. X minus 2y plus 10 is 0. Right? I think that's it. Okay, I'll stick that back up in a sec. Let's just go look at that. What did we have? 3 times the root of x plus 1 square root x plus 1 and what was that? X minus 2y minus 2y plus 10. At the point, what was the point? 8, 9, right? 8, 9. So somewhere up here. It's not, it's interesting, it's not showing me the point. But kind of looks it, right? Okay, so didn't show the point. I'm disappointed. Yeah, wait till you see the. For y equals negative 2x squared plus 3x minus 5. Determine a simplified expression for the slope of the tangent at x equals a. So this is a little bit more general. I mean, actually, it is just general, right? It's like, so what's a general formula for the slope? Like, instead of having to calculate this slope at every particular point, because now I want, like, determine the slope when x is 5, when x is negative 2, right? So if you think about it, well, then what would we have had to do? We'd have had to go through the whole formula thing, once for x equals 5, and then once again for x equals negative 2. But instead, if we can get a simplified expression for that slope, then we can just go in and throw in our a value, right? And say, okay, when it's 5, what's the slope? When it's negative 2, what's the slope? So we do the same idea. Okay, but in this case, we're just going to leave a's, right? We're not going to put in a value. Okay, we're just going to leave it as a. All right, wait, so before, negative 2x squared plus 3x minus 5. Okay, so f of x is negative 2x squared, short-term memory problems, plus 3x minus 5. Let's put parentheses around that, just so then I'm subtracting. And then f of a is going to be, well, the same thing, but with an a instead of an x plus 3a minus 5 over x minus a. Okay, and now we're ready to kind of start simplifying this, right? Okay, so removing brackets, we get negative 2x squared plus 3x minus 5 plus 2a squared, right? So we've got minus and minus. Minus 3a plus 5 over x minus a. Now, the examples up to now have sort of indicated that we should be able to get an expression on the top to cancel with the expression on the bottom, right? Like through factoring or something. So let's kind of try this. What if we go negative 2x squared plus 2a squared plus 3x minus 3a. So I'm just kind of grouping, right? I'm going to group the terms that have like a 2 and squareds, and they got 3 and whatever. Can we pull an x minus a? Well, I can see it in the 3, right? Then you got plus 3 bracket x minus a, right? We can factor 3 out of that. What can we factor out of the negative 2x squared plus 2a squared? 2.
Negative.
Yeah, maybe negative 2, right? What would that give us if I took a negative 2 out?
Positive x and negative a.
Positive x and a negative a. Okay, so what's that going to say? So negative 2, and I got x squared minus a squared. Aha, but, right, that's going to factor, right? Plus 3 times x minus a. Ah, well look, what are we going to do with this? Difference of squares, we're going to factor it. We'll get an x plus a and x minus a. We'll get the x minus a's. They're going to cancel, right? And we're away to the races. Okay, so what do we got? Negative 2, x plus a, x minus, let's clean that up. X minus a plus 3x minus a over x minus a. So what do you want to do? Just cancel the x minus a everywhere it appears, right? Okay. I could factor it out of the top separately in that, but that's kind of a, bit of a wasted thing. Yeah, it's just sort of, okay. It's in this term, it's in this term, it's down here. So we've got the limit as x approaches a of negative 2 x plus a plus 3, right? Negative 2 times x plus a plus 3. So what do we do with that? Well, we could put the a in now, right, if we want. Okay, so now no more limit, right? This is where the limit drops off. So keep your limits. Make sure that, when you're doing the test on Tuesday, and you're doing a limit like this, that you keep it until the point where this has been crossed off and now you can substitute in. So what do you get? Negative 2 a plus 3, which is what? Negative 4 plus 3. And that's the slope, right? So the slope should be negative 4a plus 3. And we'll do the rest up top. I know it's not much. Okay, so this will be 4b. So the slope is negative 4a plus 3. So when x equals 5, slope will be negative 4 times 5 plus 3, or negative 23. And when x equals negative 2, the slope will be negative 4 times negative 2 plus 3, which is 11.
Negative 4 times
Negative 17, right?
Yes.
Okay, and then one last one, which we'll do on a separate page, which is what? Determine the value of a, so the tangent to y equals negative 2x squared plus 3x minus 5 at a is parallel to 3x plus y equals 6. Okay, right, yeah. So determine, so what do we want? We want to be parallel. Okay, hang on. So what information are we carrying over here? We know the slope, right, which is m equals negative 4a plus 3. Okay, so parallel to what? What was it? 3x plus y equals 6? Okay, so what do we got to do first?
Put it in slope intercept form.
Yeah, put it in slope intercept form. So what is it?
y equals negative 3x plus 6.
Okay, which means that its slope is
Negative 3.
-3. So a slope that is parallel will be what? -3, right? Same slope. If we're perpendicular, then we would have gone positive 1/3, right?
Oh.
Okay, 'cause it would be the negative reciprocal, so we'd have to go. Okay, but it's not, it's parallel to the same slope. Okay, so what's the deal? I want the slope to be -3, and we know, so we want a slope of -3. A slope. And we know that m is equal to -4a plus 3, so -3. So -6 is -4a, so a is 6/4, or 3/2. Okay, what were we finding there? The value of a, so that the tangent to -2x² plus 3x minus 5 at that point will be parallel to that line 3x plus y equals 6. Okay, I could graph that, but it's way too much work. Okay, so, but you can plug it in.